Um, so that if that is your preference, those slides for the second lecture is now available. Okay, nice. Okay, so I guess if no one has any uh, questions, let me go ahead and get started on units of measurement right here. And get my blackboard up. There we go. Something left over from a little math tutoring yesterday. Let me clean that up. All right. So units of measurements, like I said, so here's a couple for demonstration purposes. Someone is 1.7 meters or 65 inches, 58 kilograms or 128 pounds. They're going on a 2.1 kilometer or 1.3 mile walk. Temperature is 22 degrees Celsius or 72 degrees Fahrenheit. And backpack that the young lady is carrying looks like it is 12 kilograms or 26 pounds. So hopefully you're at the point where you could convert between those units of measurements. If you are not, you will know how to do it by the time end of tomorrow's lecture and the time you've done the homework with any luck. Well, not with any luck, with just a little bit of work. Bring you up to speed. Okay, thank you. Everyone logged in. And so just so I see if there are any, where we're at, does anyone know if we were talking about Kelvin rather than 22 degrees Celsius, 72 degrees Fahrenheit, how we would convert 22 degrees Celsius to Kelvin degrees? Is that ringing any bells?
I have no idea.
Yeah, I don't think we covered that.
So just keep the number 273 and kind of file that one away because negative 273 degrees is as cold as anything can get. That's where you literally have no motion of molecules or atoms anymore. And so to get to Kelvin, you'd simply add the number 273 and change the Celsius to a K for Kelvin. So but we'll see that. That is one that can. And you do have to, particularly when we're doing the gas laws, you're going to have to be kind of have the Kelvin conversion at hand to complete that. All right, so let's start at the top here with the basics. The metric system is fortunately the system that we use in science, and a variation on the metric system, the SI or International System of Units, is the one that is used primarily in science, but they're closely related. Base 10, just moving decimals to move from one unit to another within those two systems for the most part. So for volume in the metric system, we use the liter. It's a cubic meter in IS or SI. Meter, and meter is in both systems. Mass in the metric system is grams, and we start with the kilogram as the base unit in SI, but still just 1,000 grams to get to the kilogram. Celsius, okay, we'll take, of course, a look at temperature, and then, of course, Kelvin, which I've already mentioned. And when you see Kelvin, think 273 degrees. And seconds is both. We don't have a base 10 measurement of time at this point that we use. Okay. Okay, so let's look at volume curves. In the SI unit, so a cubic meter, that's pretty darn big. If you think about how large a meter is, that's pretty big. You probably couldn't lift a square meter of water. And a milliliter is much smaller than that, a thousandth of that, as a matter of fact. So some things. So I get asked all the time, am I going to have to memorize all the different conversions between English or American system and metric system? No, I'm going to qualify that no, because there are some ones that you do just kind of want to put away in your memory banks. If nothing else, so that when you're a traveler, and I expect all of you, if you are not already travelers, when you go to other countries, they use the metric system, and we are used to the American system for the most part. And being able to do those transitions or approximate them mentally is going to be extremely helpful at some point in your life. And you'll be in Canada or Switzerland or Japan or something, and you go, oh, okay, I remember Mr. Mott. And they say, you flip on the news and they say it's 20 degrees outside. And we would think 20 degrees, oh, that is frigid. But actually, in the metric system, 20 degrees is a very comfortable spring day, about 68 degrees. And I will give you a kind of a rule of thumb to convert temperature, because I kind of had to learn that. I used to, way back in the day, race triathlons in Europe, and they would give the temperature of the water we're going to be diving into to do the first leg of the triathlon. Swim, bike, run, for anyone who doesn't know what a triathlon is. And you could wear a wetsuit, but you don't want to wear a wetsuit if the water's too warm. So I had to figure out a way to figure out in my mind, because we didn't have little computers in our hands we were carrying around back in the 90s. That's long ago. So I had to figure out a way to kind of figure out whether or not I had to unpack my wetsuit or not for the first leg of that. What else is it useful? I remember my buddies and I used to go up to Canada. Grew up in northern Montana, not too far from the Canadian border, so we would go up there, and we thought, first of all, the speed limit seemed really weird, because we would see speed limit of 100 on the side of the road. We're like, oh, okay. So we take it up to 80, 90 on these roads, before we pointed out that 100 is only about 60 miles per hour versus 100 kilometers per hour. And what else? Getting gas. You'd go in and to get gas, and you'd see gas is only $1. You think, we better fill up, forgetting that it was the price of gas per liter, and you need to multiply it by several times, and it was significantly more expensive than buying gas by the gallon back at home. So, good stuff to know. With all that being said, so a liter is 1,000 milliliters. Okay, so a liter is approximately the same as a quart. Okay, so that's an easy one. Okay. And so length, that is volume. Length. So they use the meter in the SI system, centimeters, but you can easily convert from centimeters to meters by multiplying by 100 or dividing. If it's in meters, you need to get to centimeters, divide by 100. If you have centimeters, you want to go to meters. You need to, if you have centimeters and you want in meters readings, you need to divide by 100, and vice versa if you're going the other direction. Okay. And again, useful things you should probably, if you don't have these committed to memory, just to make your life a little easier at some point. A meter is 100 centimeters, obviously. A meter is slightly longer than a yard, but the ballpark, about 3.5 inches longer. Okay, and 2.54 centimeters per inch. Okay, so that's a good one to remember, 2.54 centimeters per inch. As you're getting used to converting these things kind of in your mind. And this isn't even chemistry or science skill, this is just life skill. Okay. Okay, so on to mass, and we're looking at kilograms in the SI unit, which is 1,000 grams, grams being the base unit in the metric system. Okay, so easily to convert just by moving your decimal point three ways to the left or the right, depending on which direction you're doing the conversion. Since it is a base 10, we just need to multiply or divide by 1,000 to move from kilograms to grams and from SI to metric. Okay, good rules of thumb for mass to remember. Kilogram is 1,000 grams. Definitely, especially when if you're in a clinic where you need to have approximate weights. I see this a lot more, not so much in dental hygiene, but nonetheless, it's a good bit of information just file away in your random facts data bank. A kilogram is 2.2 pounds. Okay, definitely that second one, 2.2 pounds in a kilogram and 454 grams in a pound. Not so much there really, but definitely kilograms to pounds, pounds to kilogram. Excellent way to remember. Okay, temperature, last but not least, well, time, I'm not going to, so nearly last and certainly not least is temperature. We're looking at Celsius and Kelvin. We're not even going to look at Fahrenheit particularly today, other than to know that you need to be able to convert from Fahrenheit to Celsius and Kelvin. Okay, and from Celsius and Kelvin to Fahrenheit, because you might get a question that asks for you that you express it in the appropriate units and make sure that you know how to do those conversions. So the Celsius and the Kelvin scale. So water freezes, of course, at 0 degrees Celsius, 32 degrees Fahrenheit. Okay. And water boils at 100 degrees Celsius or 212 degrees Fahrenheit. And as I mentioned, on the Kelvin scale, absolute zero, things literally, just like you can't go faster than the speed of light, you cannot get any colder than 0 degrees Kelvin, where all motion on a subatomic level absolutely stops. Okay, so if you were able to go down and look at a molecule, you would see no motion down there. Okay, so here are 3 different thermometers. We got Kelvin, Celsius, and Fahrenheit. 0 degrees is the same as minus 273 degrees. Okay, absolute zero, or the same as approximately 460 degrees Fahrenheit. Okay, up to the freezing point of water is 0 degrees Celsius in the middle. That is 273 degrees, so we've added 273 to 0 to get the conversion expressed for Celsius as Kelvin. Just added 273 to it. And of course, 32 degrees Fahrenheit is the freezing point of water. And let's move up. Let's skip room temperature for now. I'm going to circle back to that one just a little bit. And 37 degrees Celsius, that's a good number to remember because it is of course, normal human body temperature. Above that, you're hyperthermic. Below that, you're hypothermic, equivalent to 98.6 on the Fahrenheit scale. And you'll notice if you add 273 plus 37, you'll get 310 degrees Kelvin is the same as 37 degrees or 98.6. Okay, 273. And then all the way up to the boiling point of water on the Celsius scale, we have 100 degrees Celsius, 212 degrees Fahrenheit, and 100 plus 273 takes up 373 degrees Kelvin is the boiling point of water. Okay. Everyone doing okay so far? Hopefully a lot of review.
Yes.
Just review. Maybe you haven't seen it in a while. And yeah. Okay. So. Nope. Okay. Where did I put my dear departed? There it is. Okay. So this is another life hack. So if you're just not comfortable terribly, let's say you're celebrating graduating with your dental hygiene before you start working, you're going to go on a trip to the Mediterranean. I'm drawing a picture here for you. And you get up, stretch your arms, look at the local news in Rome, and you see that the temperature outside is 10 degrees. You know it's Celsius. Okay. Do you know if you're going to need a jacket or not without calculating too terribly much or pulling out your cell phone and all that? I don't know. Maybe, maybe not. So, what I came up with, this is a Mr. Mott thing, and is the following. So we know we've already established that 0 degrees is the same as 32 degrees Fahrenheit. All right? And for every 10 degrees Celsius you go up, you add 18 to the Fahrenheit number. 32 plus 18 is 50. 20 degrees Celsius, I'll get you up to 68. At 30 degrees, so a nice 68, nice spring day. 30 degrees, now we're getting warm at 86. I had to think about that. Okay, 30 degrees, 86. Now we're getting up to a summer day. And 40 degrees, now we're getting hot. All up to 104. Okay, so if you just memorize this, start at 32, add 18 degrees. No, 30 degrees is 86, 40 is 104, yada, yada, yada. Then if you get the in-between numbers, you can kind of guesstimate. Say 15 degrees is going to fall right between 50 and 68. So you're going to know that's going to be up in the 60s-ish, right? Low 60-ish. And so on. Like 27 degrees, we're going to be pushing 80 degrees Fahrenheit, etc. But memorizing these is going to help you in those situations, so you'll have some idea of what people are talking about. Unless there's some of you probably have relatives or visit Canada with some frequency and are a bit confused. All right. Kind of cool. I thought. I'm very proud of myself.
So for every 5 Celsius, it's basically 9 or 10 Fahrenheit.
Yeah, 9. Well, yeah, every 5 is 9 degrees. Sure. Yeah, absolutely. Good call. I think that was Derek. I think I recognize your voice.
That's me.
Okay, perfect. Yeah. So there you go. Now you can be international men and women of mystery and know basically if you should wear a jacket when you step out of your room. All right. So time is straightforward. We use seconds, seconds, seconds in all 3 measurement systems. Not an issue. So that's all the time I'm going to spend on seconds. Everything is per second. And I'm not going to worry too much about this quick quiz here. Bag of onions is mass. Meters is length. Grams, again, are mass. And liters are volume. Okay. Measured in numbers, unfortunately, I don't have a lab in this class. This would be much more important. But it's an important concept to keep in the back of your mind. You can only measure and approximate as accurately as the tool you have. So, for instance, here, all we can really say is that it's with any certainty is it's between 4 and 5 centimeters long. Okay, so you need finer gradations to start adding decimal accuracies. Okay, so same measuring. We have 4.5, so we know it's between 4.5 and 4.6. So our guesstimate is going to have to be between 4.5 and 4.6. Okay. So 3 centimeters here, only between 3 and 4 once again. So which of those is accurate? How long is that red line, assuming it lines up directly over one of the dots?
Is it 9.2?
9.2. Yeah. So for anyone, the next big line is the 0.5 halfway between 9 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, the full centimeter. So 9.2 is exactly right. Okay. So yeah, don't get thrown off, particularly if you're drawing something up for the love of everything. Pay very close attention when you're drawing something up into a needle. Make sure that you're reading the barrel of the needle correctly, so you're not. I certainly have a fair number of people who will say that is 9.4, thinking that the 10 fell on the next thick line. Okay. For prefixes and inequalities. Okay, I'm going to hit this next one a little quickly again. Then in my review, I'm going to circle back to it. So prefixes, kilo is 1,000, milli is 1,000th. Okay, so all you have to do is go to those base units and add those prefixes to go between the various units in the metric and the SI system. So kilo is 1,000 of something. Milli is 1,000th of something. So here are some big ones that you probably, well, above kilo, but mega is 1,000,000, giga is 10 to the 9th, and tera, 10 to the 12th. So you see these numbers more like computing power, more than biology or biochemistry, but they are out there, and I'm sure there's some computer whizzes out there who've seen those. And then the numbers get very small here, as small as we generally go when we're especially dosing medications, because some of the medications we use are very potent. Micro, like Synthroid, is dosed in micrograms. Okay, 10 to the minus 6th or 1,000,000th of anything. Okay. And this is a chart. Most of what we'll see in healthcare is between kilo down to micro, maybe nano. And then you see these other much larger numbers: tetra, peta, exa, zeta, yotta. Yotta. I've never seen yotta 10 to the 24th, but it's a whole lot of something. And in fact, that 10 to the 24th is 1 power larger than 10 to the 23rd is what we'll see in Avogadro's number. So there's another, that's what we call a foreshadowing of things to come. Okay, 10 to the 23rd. Okay, pico, femto, atto, zepto, and yocto. So I find it, I don't know, I'm always looking for patterns, but 10 to the negative 24th starts with a Y, it's yocto, and 10 to the 24th, which is also starts with a Y, which is yada. And down zepto, zeta, it's almost like they planned this. those opto, and then atto, and then then my pattern breaks down. But the two biggest and the two smallest both start with the same number. Okay. So you'll see these on, if you're watch your diet and look at these nutritional values of things, you'll see all of these things, grams, milligrams, microgram amounts of iodine, like an iodized salt as well. You get a little practice looking at those. A gram, a thousandth of a gram, and a millionth of a gram or microgram, all found on our foodstuffs. USDA required. Okay, and I think, why don't I leave it there? And then we'll start with prefixes, drive that point home, do a little bit of review, and then we'll be off and running with the more kind of calculation part of today's quiz. Okay. Okay, does anyone have any questions about that information? The quiz is coming up a week from Friday. Make sure, let's see how I'm looking on homework. Everyone's done their homework. Awesome. And good. Looks like everyone knows that you can go in and take it that second time and get a clean copy of that for studying purposes. Excellent. And to bring your grade up. And with that, if you don't have any questions, I will. Calculators, yes, you can use calculators. Although, yeah, you might, I would say, it doesn't have to be anything fancy. Get your hands on your own calculator if you don't have one yet. I mean, you just go to the dollar store and get one of those. They'll be fine. Quiz will be on the computer, very similar to what you saw in A&P. Because I don't know what happened to our bucket of calculators we had in the dental hygiene room, so I still haven't tracked that down. So just get your own. Like I said, you can get one for under $2 at the dollar store if you have one of those available. Doesn't have
maybe it's on the next room.
Oh, they went right next door?
Yeah. Usually I saw that bucket in that room, not in our room.
Okay. So do you know if that's where they want them to stay, or they just kind of ended up?
I don't think so. I think because of the last cohort 13, they use that room more than us, so that's why they move over there. I think so.
Okay. Well, okay. Good to know. Good to know. So I don't want to step on anyone's toes. Like just a quick. I mean, I have a TI-30, but it doesn't even have to be this fancy. And believe me, this is not that fancy. And you don't have to get like the $100 TI-90s or anything with any memory or graphing or anything like that. Just basic functions, exponents, all of that kind of stuff would be, I think.
You can use your phone too.
What was that?
You can use your phone too.
Yeah, in a pinch, and I will say that in a pinch, because normally I tell you to turn your phone over during quizzes. If you don't want me like peering over your shoulder like Big Brother while you're taking a test, have something besides your phone to do your calculations on, because people have been known to surf the web looking for answers to stuff on their phones.
I see.
And get in trouble for it, so just best just to avoid it. Good questions. All right. Okay, so does everyone know? I'll just do it again. I'll just reiterate. So inside of course content, all right, I have it open. There is a quiz. Let's see. Yes, very first thing. Attendance quiz you already did. Next quiz will be your homework for this morning's class, and then I will see you tomorrow and give you your real homework for the material that will be on your quiz. First two Fridays information will be on the class or on the quiz to start class a week from Friday. Okay. If you don't have any questions, you are free to log off and complete that. I will be here. I'll just stay online. What do we have over here? Yep. I will just stay online till 11:30-ish for y'all. And you can just log back in and ask me any questions you might have. If not, I will see all of you all tomorrow.
Cool. Thank you.